Hello, my name is Alberto Cottica and I'm here to propose a way to monitor and herd emergent social behavior in online networks. The reason I want to do it is that I would like to do policy on it, and policy is very badly broken and can't process the information necessary to govern a complex society like the ones we live in today. So a possible fix would be to harness the incredible information processing power of online communities directed by shared values. The problem with that is that online networks famously steer by endogenous social dynamics. There is no element of top-down command and control over them. And that's not going to be good enough if you want to use them to do policy, because by definition policy needs to meet some exogenously set goal. So doing policy with online community means solving a paradox, which is to be able to design for emergent social dynamics. And how would you do that? Well, it may be paradoxical, but it certainly is not impossible. There are already out there great communities that do seem to meet some exogenously set goal, like for example that of writing encyclopedias. You can't deny that there is a lot of emergence, but also important elements of design in stuff like Wikipedia. I would argue that even a lowly blogger or an expert Facebook or Twitter user is going to have some kind of feel of how to design for emergent social dynamics. The way they write, what they write about, is going to elicit a certain sort of response from the readers. I would say hundreds of thousands of people out there have hands-on experience on how you might do that. As we speak, complexity scientists are at work to devise a theory of emergence in the social world. We already have a functioning theory of emergence in the natural world, where agents are dumb, like molecules or neurons. That doesn't really help us to understand it in the social world, where agents are smart, like people or organizations, but we hope we can get a result out of that. And once the theory is there, I would propose that we start by taking advantage of the fact that an online community is, after all, a network of relationships, and as such it can be described in compact form as a graph. So you might look for correspondences among higher level social interaction when people are involved and mathematical characteristics of the graph. Here's an example. Kublai is a project of the Italian Ministry of Economic Development. The idea there was to have an online community of people from the creative industries that collaborated in developing business ideas that could then be launched. I am its founder and director. Here's how Kublai works. People join the network and then they can start projects or collaborate on somebody else's project. And naturally, people self-select to collaborate in the projects that they are interested in or they just like. You can visualize Kublai as a network where projects connect different people. In 2009, Ruggero Rossi conducted a network analysis on the graph representing Kublai, and he found something interesting. A group of about 20 people had formed a K-core, and the K-core is a structure where every node is connected to every other node, and it doesn't break down even if you take away K nodes. Who were these people? Well, they were, of course, the team's paid staff, but the team's paid staff number was less than K, significantly less than K, about 6 people. So what that means is that even if you took away all of the paid staff, you would still have a bunch of people that were tightly connected to each other. And we made the hypothesis that these people would perform an essential role of transporting information from one project to the next, thereby increasing the efficiency of Kublai in processing information, because if a group reached a solution to a particular problem in project A and the same problem presented itself in project B, people in A participating also in B could say, look, these guys have solved this problem already. So this would reduce duplication. And if this was a good thing, we wanted more of it. So we tried to bring the senior people together in a group called Club dei Progettisti, which is not tied to any particular project, but it was just thought as a meeting place of people who were seen as key in the community. We invited everybody in the K-Core, and we invited other people that ran their own projects. The idea, as I said, was to enhance the spontaneous social dynamics that was leading to more sharing of information, at least according to our interpretation. Today, this group is by far the largest in Kublai, and it has more than 200 members. I was the director of Kublai. I spent a lot of hours a day surfing the network and participating into it, and I prided myself with knowing it really, really well. Despite this, when I saw the results of Ruggero analysis, I went, wow, this sounds really plausible. It's actually giving me some new perspective on an item that I thought I knew like the back of my hand. So what's going on here? Well, on the one hand, Ruggero was giving me an alternative view mode on my own network. So it was like in a game, you can toggle between different new modes, and this was giving me perspective. But there is more. As the network becomes larger, it doesn't get any harder to spot a K-core, at least in principle. So you could say that the view mode of the graph scales quite well. On the other hand, the view mode of the social interaction taking place in the network doesn't scale so well, because you can know everybody in a village, but you can't know everybody in a metropolis. So it just makes sense to use the view mode of a graph as a diagnosis tool and a way to suggest policies to roll out, and of course to use the view mode of the interaction of taking actually place in the network as a place to take steps. So our goal would really be to augment community management, to give a community manager this kind of X-ray vision that she would look right through the wealth of social interaction going on and see the underlying mathematical structure of the graph and draw conclusions from that. How that might work? Let's take a closer look. The way I think about this is that we would have a little robot which helps the human community manager do her job. So the first question to answer is, what's going on in that network? And the little robot could carry out some kind of analysis, network analysis the way we think of it, and then turn the metrics of the graph into interpretations in the natural language as to what these metrics might signify at the level of the social interaction among the people in the network. And of course, the human community manager would have to validate that interpretation and to say, like I did in Kublai, yes, this makes sense. This is what could be happening. The next step would be to figure out what to do. And in this sense, the little robot could suggest courses of action. And again, the human community manager would have to choose among the choices that the robot gives her. Step 3 is quite tricky, and human community managers are not very good at that. It is setting quantitative targets. So in the case of a K-core in Kublai, it could be, let's try to get the number of people in the K-core up from 25 to say 60, and let's get K up from 11 to 30. And then the human community manager would have to agree to the target and then roll out the policy. The final stage would be to assess how the policy went after it has had time to perform its magic. This would be again done by analysis, probably the same kind of analysis that was performed before the policy was rolled out, and the little robot would do it. And then he could check whether the targets were met. And if they were met, then this probably means that the whole chain of interpretations, from mathematical characteristics of a graph to interpretation to courses of action to targets setting, was consistent. And that would mean that the knowledge base underpinning the little robot's advice is solid. And then he would want to update this knowledge base in this sense. Of course, if the targets were not met, then he would have to look for an error somewhere and maybe update the knowledge base in a sense of weakening it. And he could also send a report to the people maintaining the knowledge base, the programmers of Dragon Trainer in a way. And then he could offer an interpretation for what's going on, and again the human community manager would subscribe to that interpretation. Okay, so here's how you diagnose, but how do you actually influence behavior in an online network? I think of it as dragon training because it's akin to trying to train a very large animal which you can't really bully around. You have to convince a large animal like a dragon to do whatever you want him to do. And there's two ways that this is typically done in online network. One is by carefully managed information loops. So here's what the community managers of Critical City Upload did to increase the quality of the mission performed in their game. They created a Hall of Fame. It's as simple as that. So if you had done an excellent mission that they recognized as excellent, you were given high visibility in the net and kind of praised for it. This would create an incentive for you to do more of the same, and also would give you a direction for what quality is in that particular context. Also, this information would be recycled. Not only the player who did the mission, but also other players could look into the Hall of Fame and figure out what a high quality mission is in the context of Critical City Upload. And the second method is by locally enforced interaction rules. We knew from complexity science in the 80s that you can have very elegant patterns emerge from local interaction rules. Now, community managers typically have in their network some kind of authoritativeness, and they can use it to get some people to coordinate in doing something at the same time. For example, let's give a welcome to newcomers in the network. And then they can hope that this behavior will spread from the surroundings of a community manager themselves to the general network, which can happen if there's multiple equilibria in that particular choice. That's all, folks. For any questions or comments, I'll be grateful if you contact me. I'm Google friendly. My name is Alberto Cottica. My blog is alberto.cottica.net. Bye!